Hi everyone, welcome to another video. In this video we're going to be working through solving certain equations using logarithms, but before we do that we're going to introduce something that we call the change of base law of logarithms. So I actually applied this in a previous video a few videos back in this series, and I said we'd get to it a little bit later, so we're going to talk about this now. And the change of base law we use for when we want to evaluate logs in our calculator. So let's just look at some regular equation to talk about our change of base law. So if we say, for example, some number a to the power of x equals to y. Now, this is very tricky to solve. Now, let's just pick sort of two arbitrary numbers. So 2 to the power of x equals to 7. Now, what's hard here is that we don't know a power of x that produces 7 as an answer when you take 2 to the power of it. So we're going to come up with this and find an approximation using what we call the change of base law. Now, what this basically involves is that when we try to work through these equations, we want to do something to both sides to essentially get the x on its own and everything else on one side. So just like any operations, so think back to the first time we're solving equations. We noticed that we could, for example, multiply both sides by 2. We could do any operation to one side, and what we did to one side we did to the other. What we're going to do now for this change of base law is that we are going to take the log of both sides. And what we're going to do, because our calculators have these different buttons, they've got a log button, most scientific calculators, and they have an ln button. Now, the log means log to the base 10. So we're going to be using our calculators for this, and ln is log to the base e. This guy over here, we're not really going to talk about in this video. We'll talk about that a little bit later. We're mainly going to be focused on this button, which allows us to evaluate logs. So what we're going to do is we're going to take the log to the base 10 of both sides. And what we're going to get here is we're going to get, on the left-hand side, we're going to get log to the base 10 of a to the power of x. And on the right-hand side, we've taken the same log to the same base of that term on the right. Now, what we're doing here is that now our log laws tell us that when we have a log to some base of a number with a power, we can take the power down to the front. So that's exactly what we're going to do. So taking that to the front, we're going to get x times log to the base 10 of a equals to log to the base 10 of y. And now, because the operation that's happening here is x is multiplying by log to the base 10 of a, we're going to get the x on its own, we're going to divide both sides by log to the base 10 of a. So what we get here is x on the left-hand side, and on the right-hand side we get log to the base 10 of y over log to the base 10 of a. So if you were to put this in your calculator, you just press the log button and then whatever term this is, and you do the same thing to the bottom. So we're essentially getting a new base. We're using a different base, a base of 10, which is programmed into our scientific calculators to evaluate certain logs, or certain equations, I should say. Now we're going to do that with this particular example here, as well as another one later. So here, what we're going to do is, actually, let's change these numbers up. What we're going to do here is that we're going to take the log to the base 10 of both sides. Now, basically, some of you might be wondering, well, can't I just rewrite it as in log form? So this is in exponential form, so can't I just go log to the base 3 of 5 equals to x? We can do that, but there is no way to write this into your calculator to evaluate this without using a base that's programmed into the calculator. So this is what we were talking about before, log to the base 10, which our calculator has on the log button, or log to the base e, this ln button that we have. So what we're going to do instead, we're going to take a change of base. So that's going to give us a different base down here and allow us to evaluate this with our calculators. So let's take the log to the base 10 of both sides. So I'm going to get log to the base 10 of 3 to the power of x equals to log to the base 10 of, 5. I have just taken the log to the base 10 of both sides. I've done some kind of operation and applied it to both sides in the same way we've done many times with equations before. And now what we're going to do is we're going to remember that we can pull this number, this power, out to the front. One of our log laws that we talked about before tells us this. So we get x times log to the base 10 of 3 equals log to the base 10 of 5. And now we just want to divide both sides by log to the base 10 of 3. That's going to give us x on its own on the left-hand side, and it's going to give us a way to evaluate this now. So we get log to the base 10 of 5 over log to the base 10 of 3. And now we can put this into our calculator. So to put this in your calculator, you're going to set up a fraction, and you're just going to write log of 5 over log of 3. The calculator automatically, with this log feature, assumes to the base 10. That's how our modern scientific calculators are programmed. So let's try one more example so we can sort of get the hang of this. This one will be slightly trickier. But what we want to do is we want to solve this thing over here. So 1,000 times 0.93 to the power of x equals to 100. Okay, so this is a slightly more extensive equation that we have. First of all, we can't apply our change of base to this thing here until we get rid of this 1,000 multiplying out the front. So what we're going to do, we're going to do what we do with all of our other equations. This is timesing by 0.93 to the power of x. We can undo the timesing of 1,000 by dividing both sides by 1,000. So this is going to give us 0.93 to the power of x equals to 100 over 1,000. This just simplifies to 0.1. We can write this as a decimal. You can leave it as a fraction, but a decimal is just a little bit neater to write into your calculator. So what we're going to do once again is we're going to take the log to the base 10 of both sides. So here on the left hand side I have log to the base 10 of 0.93 to the power of x equals to log to the base 10 of 0.1. And now the exact same thing happens. We want to find a way to get to this power. So we're going to use our log law we talked about before to bring this power out the front. 0.93 equals to log to the base 10 of 0.1. And now we can just divide both sides by log to the base 10 of 0.93 to get us to our x over here. So we get log to the base 10 of 0.1 over log to the base 10 of 0.93. And now our calculator lets us actually do this because it has our log button programmed to the base of 10. Now that's going to give us to a couple of, we'll say 3 decimal places, 31.729. So what we're doing here is we're solving these log equations, these exponential equations, and we're giving approximate answers. So something like this one, for example, I just realized I didn't give you an answer for that. I got too carried away. This gives us, in a previous example, this one up here, we get the answer of 465. Okay, now let's actually just think about this for a minute. We're looking at 3 to the power of something equals to 5. We're going to look at how these approximations work. Now, we know that 3 to the power of 1 gives me 3. 3 to the power of 2 gives me 9. Now, 5 is somewhere between 3 and 9. Now, it's somewhere around the middle-ish, but closer to my 3 over here. So this answer of 1.465, slightly less than half between 1 and 2, kind of makes sense. So 3 to the power of 1.465 gives you approximately 5. So our answers here are really just approximations, but you can do this little sense check as you're working through the questions in order to check that your answer makes sense, especially when you're dealing with numbers of which you know their powers pretty well, and you can test this as well. This is how the change of base law works and how we can apply it to solving certain exponential equations.